Good afternoon, and welcome to today's webinar, Safe by Design, Security Glazing and High-Performance Glass in Educational Facilities. This event is brought to you by Architectural Record as part of its Academies of Digital Learning program, a program that allows architects to fulfill some or all of their annual CE requirements within individual education academies focused on specific areas of design interest. This webinar is part of the Glass and Glazing Design Academy, sponsored by the National Glass Association. I'm your moderator, Dean Evans. I direct the Center for Building Knowledge at the New Jersey Institute of Technology. Thank you all for joining us today. Today's presenters are Ron Madeley, David Dumas, Jamie Gascon, Teresa Ham-Modley, and Urmila Sowell. Ron is Principal Engineer and Business Interface Leader with the Technical Glass Products. David AIA is an Associate Principal with the Beck Group. Jamie is the Board and Code Administration Division Director with the Miami-Dade County Department of Regulatory and Economic Resources. Teresa AIA, Lead AP and CPHC, is an Associate with VMDO. And Urmila is the Vice President, Advocacy and Technical Services with the National Glass Association. As we work through the webinar today, don't forget to submit your questions, and later in the program, our presenters will address as many as possible in the time remaining. Today's event is also being recorded and archived on architecturalrecord.com/webinars. This course is approved for 1 AIALU HSW, 0.1 ICC CEUs, 0.1 IACET CEUs, and 1 AIBD-T-CE. It may also qualify for learning hours through most Canadian architectural associations. To qualify for credit, you must watch this webinar for a minimum of 45 minutes. Following the event, live webinar attendees will receive an email with instructions on how to view and download your certificate of completion. You do not need to be an AIA member in order to receive a certificate. An archived version of the webinar will also be posted to the ArchRecord CE Center website within 24 hours, so that any of your coworkers who couldn't attend today or any other colleagues who might be interested in the topic can easily access the information we will be presenting. Please note that those who access the archived version will need to complete the entire webinar and then also take a 10-question quiz in order to receive credit. This presentation is protected by U.S. and international copyright laws. Reproduction, distribution, display, and/or use of the presentation without written permission from the speakers is strictly prohibited. The learning objectives at the end of this webinar, participants should be able to describe the key threats to school safety that security glazing and advanced glass technologies are designed to address, including force entry and ballistic impact. Evaluate glazing performance characteristics and industry standards such as ASTM and UL testing protocols that ensure safety and compliance in school environments. Identify design strategies that integrate security glazing without compromising daylight, views, energy efficiency, or overall learning environmental quality. And finally, apply principles of health, safety, and welfare by specifying glazing systems that enhance student protection, support code compliance, and contribute to resilient educational design. And now I'm excited to turn over today's webinar to our first presenter, Urmila Sowell. Urmila.
Thank you, Dean, and thank you all for joining us today. Our presentation, like Dean mentioned, have our learning objectives, but today we'll cover relevant codes, standards, and we have a few architects that will go through some of their case studies as well and show how security glazing is incorporated into their design work. The National Glass Association is a non-for-profit trade organization. We have about 1,900 member companies, and we span the entire supply chain, including the flat glass manufacturers, the fabricators, the glazing contractors, and full-service glass companies, as well as suppliers. And NGA's vision is that we envision a future in which glass is the material of choice to enhance spaces where people live, play, learn, and work. For us at NGA, the glass is not just for residential and commercial, but glass is being asked to do so much more in our homes and buildings. It's the only building envelope material that is capable of doing so, and so much more. You can screen all of the different levels of impacts and applications for glass. So why are we here today? Within NGA, we believe that for school security, that windows and doors respond first. This chart that you're seeing goes from the 1970s all the way up for the 2020s. And as of yesterday, we've had even more. For 2025, there were at least 100 incidents of gunfire on school grounds, resulting in 32 deaths and 98 injuries nationally. So what can we do about this? Back in Sandy Hook in 2012, similar to Hurricane Andrew in 1992 was a catalyst for windborne debris codes and hurricane testing, Sandy Hook motivated members in the glass and glazing industry community to act. Companies began looking at school security and security glazing products available and realized that there was nothing designed specifically for schools. Most were intended for banks or embassies. So as such, within the organization, new products were born, as well as new standards. And since 2014, the National Glass Association released information and bulletins on school security, security glazing for schools. What we have all seen since Sandy Hook shooting in 2012 is that time is critical. The average length of an active shooter event is 8 minutes. The shortest has been 90 seconds. And the respond time for first responders, the average about 3 minutes. Some active shooter events are over before the first responders arrive. And what we would like to say is that your glass and glazing can respond first. It can buy that time. Right now, there are no building codes for school security. In comparison, every building is subject to fire codes and fire regulations because 92 students and 3 nuns died back in 1958. So it took one incidence of a fire in a school for them to have fire-rated information, fire-rated codes in schools. The National Glass Association and the Glazing Industry Code Committee has a code proposal for the 2027 IBC in which we're advocating for that fenestration systems that are in certain areas of the school be tested to ASTM F3561. In F3561, it's the standard test method for forced entry resistance of systems after a simulated active shooter attack. Serves the industry. It's an adopted minimum criteria for security as well for doors and windows. We believe that glass can be a security plan as the first element of surprise. This standard it incorporates force entry, responder enhancement, mechanical testing. It's reproducible, has several levels, eight levels actually, and it's a consensus standard. There's a lot of information out there with different standards and different specifications. However, this is the only consensus standard that's been internationally done. And it has a systematic review every couple of years and as needed. I'd like to show a video, and this is after the ballistic portion of the testing. It goes through an impactor test. And as you can see in the video, this has not just the glass. It's not just a glass test. It is a door. It's the framing system. It is the hardware. It's all part of it. And so it is not a ballistic resistant. The bullets can go through this according to this standard. However, it does not leave an opening at all. As you can see, the impactor is there after the ballistics, the ballistic portion of that. And the door should not be open. There should not be an opening to where someone can then enter the school. Window and door solutions. Right now, we would like to say that the security glazing resistant to force entry can be used to slow down an attacker, allowing time for schools to enact emergency plans and for first responders to arrive. Allow the school personnel and first responders to see the impending danger. So that's why you have the windows there. So that way they can see what's happening and be able to alert and then be able to adjust what they need to do to get their emergency plans going. It also provides privacy and allow diffuse light. Of course, many of you as architects know you want the light in schools, so that way the students can have better test grades and show up in school and be aware of what's going on. And it also selectively blocks attackers' line of sight on when translucent or reflective glass is used. It can be designed for forced entry resistance and or bullet resistance, and there are options for retrofit as well. We like to create a secure environment for teachers and students without imposing visible barriers, and of course provide passive protection even during power outages. I'm going to turn this over now to Jamie Gascon, who will tell us a little bit more about Miami-Dade County's approach. Jamie?
Thank you, Irmela. In my segment of the presentation, I'll be talking to you about 4 key aspects that are front and center here in Miami-Dade County. First off, we're in the midst of the development of the 9th edition of the Florida Building Code. And in doing so, we've presented a number of code changes that are specific to glazing, one of which is the development of a new testing protocol, which will address fenestration flood resistance on passive fixed systems. Another change that we've made is for checklists on testing for bullet resistance and active shooter simulations. Added to which we then have a specific testing code change for increasing in structural silicone capacities, and then as well a code change for the water infiltration on fenestration door systems. And then I'll end the segment with some structural glazing inspection requirements that are unique to our area here in South Florida under the high velocity hurricane zone. So first off, the testing protocol that's been developed recently. This would be for flood resistance test procedures of passive in-place systems. And this has primarily been developed at the request of industry in collaboration with local testing laboratories for a set of guidelines on how to go about mocking up, selecting, and testing the assemblies that are going to serve as these flood resistant barriers and conditions. The uniqueness of these fixed fenestration units is such that under the FEMA flood protections, there are some dry flood proofing conditions that are allowed by the code. And in lieu of providing alternative after the fact barriers, glazing has been more predominantly used in these dry glazed situations. So for that, the Florida Building Code does have a volume of testing protocols that are used in the high velocity hurricane zone, and this was the development of one of those for inclusion. On the testing requirements, also for bullet resistance glazing systems, we here in Miami-Dade County have developed this new checklist that's going to serve for calling out 2 additional new tests for us here in South Florida, which would be the ASTM F3279 on the standard test methods for ballistic resistance, and the UL 752 test for ballistic resistance. Manufacturers will now have the options to include these as added performance on their product approvals with Miami-Dade County. This does have the requirement that each product type shall meet the requirements per the applicable checklists, if it's a door, if it's a window, and so forth. Additionally, we also elaborated a forced entry resistance checklist to capture the performance under simulated active shooters, and that's then inclusive of the ASTM F3661 for standard test methods for forced entry resistance, similar to the video that Irmela showed earlier. And then this too would be as a complement to the type of doors and systems, glazing systems that manufacturers are seeking to qualify. From the Florida Building Codes perspective, the added change that was filed in this cycle was to increase the current limitation of the 20 psi stress limits on silicone. Presently, and I want to say that this dates back to 1988 South Florida Building Code time era. This limitation has existed there with the applicable safety factor of 5 to 1. Industry has approached us and consistently shown test evidence that capacities with current silicones far exceed that 20 psi limitation that we had in the code. So there's been a code change filed to increase that from 20 to 30 psi while maintaining the safety factor of 5 to 1. There's also some minor tweaks here on the thickness and the qualified stress that needed further adjustment due to that, and clarifies that in this code change. On the overhang and water testing of doors, this is a proposed code change that we're dealing with in concert with industry. And essentially the first round was to eliminate the exception that currently exists in the high velocity hurricane zone, that if provided with an overhang, these doors would not need to meet the water performance. In the second phase of the code development, because of the fact that that code change was disapproved, an alternate language was proposed during the allowed period. And what essentially has been now presented is to allow for the AMA limited water standard to be used. And in addition, to provide lateral protection on the sides of the door openings, in addition to just the overhang. So presently the overhang is just from the width of the door extending out from the building. This proposed alternative would also require a radius, as shown there on the top figure, extending from the edge of the door all the way back to the wall. And when you have some kind of alcove tunnel condition, that's also part of the considerations as shown there in figure B. This again is currently at the Florida Building Commission, going through the process for approval, potentially for the 9th edition of the Florida Building Code. And then lastly, I wanted to touch upon in Miami-Dade County's requirement for recertification of structural glazing. This is something that again existed in our building codes for a number of years prior to the Florida Building Code taking effect back in 2002, but which has not had the level of enforcement that the code requires. So in 2022, our Board of Rules and Appeals discussed the matter further, developed a test criteria for effecting these types of tests, and we issued and circulated this advisory memo to all building officials to survey their respective territories and identify buildings that have the structural silicone and applicable to threshold buildings. And from that, a series of guidelines were developed for both the laboratories and the building officials to follow in documenting the performance of those units. I also want to just point out that our website has been revamped. We do have now siloed the 4 sections of our Board and Code Administration section, where product approval being one of the more highlighted aspects of our website when it comes to glazing and building envelope products, can continue to be searched by either product approval numbers or manufacturers, even categories of products. to verify their continued acceptance and limits of use. So that concludes my portion of the presentation, and I believe we will hand it off now to David.
Thank you, Jamie. Yeah, I'll jump in here. My name is David Dumas. I'm associate principal with the Beck Group in Dallas, Texas. Beck is a large construction and architecture firm. We do a lot of design build, and I am a leader in the education and institutional side of the practice. Today, I wanted to talk about a case study about a project we're currently working on that's actually under construction now, Christ the King Catholic School of Dallas. This is a really great client. It is a school it's part of a church campus. The school was founded in 1947. It's K through 8th grade with 481 students and 50 faculty members. They have about a 1-to-12 ratio. When this is an addition to an existing campus, and when they came to us, they obviously had concerns about safety, and that's a conversation and part of the design process that's always ongoing. They also had concerns about the fact that the building should look like the rest of the campus. It should fit in, and also quality of teaching spaces, but also security. In talking with them and finding out their strategies and how they dealt with today's issues of intrusion, forced entry, and active shooters, they definitely wanted to protect entry of any intruders. So this area is controlled. The main entrance is on what's planned north, shown in the red, which is the entry vestibule, which is monitored by a reception area in orange. The yellow area is a storm shelter that I'll talk about here in a little bit. But from the first conversations with them, they wanted to prevent entry and prevent forced entry into the building. And this vestibule was their first line of defense. And we're using level 3 ballistic glazing in that vestibule. And the reception area is acting more like the security monitoring station and provides the first line of defense against potential threats. So the big design challenge was that the client, was that it was very important to have the protection while still preserving the welcoming feel of the main entry. Again, they very clearly said they don't want this to look like a bunker. They wanted this to be inviting. The protection is provided by using the ballistic glazing at the main entry with cameras and remote locking hardware to deny access to any potential threats. And we find this to be a good strategy, and ballistic glazing and products like that help us are able to do this. On the inside, it was very important to the client. They want to have the security, but they also wanted to feel openness. They didn't want the students to feel like they were coming into to the airport security zone or to some high-level security area. And in this case, the vestibule was designed to be basically a man trap because all of the glazing in there is ballistic rated systems, and it's controlled by the reception area, which is the security station. But using these ballistic systems, we're allowed to have the light come through, the views come through, and it feels more transparent and open. And the client was very happy with this solution. And as I said, this is all part of a process. We're in construction right now. They've got foundations down, and they should be getting steel up pretty soon. But as we moved further through the process, through approval process, the client had second thoughts about the ballistic glazing that we're using at the window that sits between the vestibule and the reception area. They thought the window looked too visually unwelcoming. It was too heavy, maybe too bank-like. So right now the design team is studying alternative window systems, investigating non-fixed options that would still provide the ballistic protection. This is definitely a process that's ongoing. The other part of this protection of the students is the storm shelter. North Texas has a lot of high winds and tornadoes and storms like that. And we're required to have protection for education in terms of the storm shelter. In this case, a lot of times the storm shelter is either a gym space or a cafeteria space. In this case, the extension, we didn't have any of those large spaces like that. And the client particularly wanted to kind of incorporate classrooms and the bathrooms that were there and a hallway as part of it. And again, the other issue was that this building is an addition to an existing church and other education structures, and they wanted to fit in with the window spacing, the aesthetics of the outside. And so we worked with that, and we also had our budgetary constraints to deal with, because originally we had designed all impact rated glazing at the windows to the building. Because of the cost, we looked at alternative shutters, storm shutters at the windows, which worked pretty well, except in a few areas where because of the wall for the storm shelter, you could not fit in the actual side rails necessary for the shutters. So we actually used a hybrid combination of the shutters and the resistant glass to provide the protection for the shelter. And again, the reason we need the shelter in North Texas is because of the storms and the winds that come through. On October 20th, 2019, an EF3 tornado destroyed a majority of Thomas Jefferson High School, which was a public high school in the Dallas Independent School District system. And also the gymnasium and several other buildings were heavily damaged on the St. Mark's School of Texas, which was a private boys' school in the same area. Beck actually rebuilt both of these buildings with new code compliant storm shelters. But you can see heavily the damage that was done to both of these facilities. As we move forward in the design process of this project, the client was very interested in trying to maximize the dollars and the spaces. And we talked about an idea of having the storm shelter not only provide shelter from inclement weather and tornadoes and straight line winds, but it could play a role in the defense and protection of the students from forced entry and active shooter situations. So again, the main entry is protected by the glazing and is the first line of defense to deny entry or to trap them if they make entry. And then the storm shelter is actually part of the lockdown system too. The doors to the storm shelter will close in an active shooter event and lock, and again slow down any intruders. And the walls of the shelter itself, which are reinforced CMU, will help protect that area, in addition to the doors and the other barriers that are already in place. So this was kind of a hybrid combined solution that the owner was very happy with, and we worked through with them to make all these aspects work. That's kind of my case study. Ron Madley was going to take it from here. Ron?
Great. Thank you, David. I appreciate that. And great segue into what I want to talk about, which is integrating high-performance glass into safer school designs. But before we get there, I want to take just a moment to briefly consider the various test standards. You've heard a couple of them already, but I want to talk about a couple of the test standards for forced entry and ballistic resistance, which glass may be subject to. The first one, and I think most everybody is familiar with this, a UL 752. It's one of the oldest standards out there. It is a ballistic test of a component or a system without any forced entry element to that test. Materials are subjected to live fire testing with specific ammunition for specific firearms, a certain number of shots at a required velocity and distance. The standard evaluates whether projectiles fully penetrate or if it allows any spall or back face fragments to get through. It's important to note that a product must pass all requirements of a given level of the standard to be certified at that specific level. In other words, the levels are not progressive or hierarchical. It was first issued in 1942, and the current 12th edition delivers some significantly enhanced clarity, realism, and rigor in the performance testing. This page, a lot of text on here, and I'll summarize this by saying the two standards on the left, you see, these were published in 2005 and 1998, respectively. ASTM E2395 has no ballistic component to the testing. It is purely a forced entry test, starting with a series of hand manipulation tests of the glazing. There's a lock manipulation followed by an impactor test and a missile impact test, as well as some force pulls that are done on the samples, then a final manipulation test again. Again, no ballistic weakening in that. Similarly, ASTM F1915 has no ballistic component to the testing. It's purely a forced entry and a pretty aggressive forced entry test at that. It requires consistent duplication of testing using a standardized test fixture, using a large blunt and a sharp impactor over a number of impacts over a period of time. These are done at both artificially cold temperatures and artificially warm temperatures. And then there's a small torch and blunt impactor test that's done at ambient temperature to simulate a sustained flame attack. So a little different approach there. Ones on the right are system tests, and we'll focus more on F3561. This is, as Armelin noted earlier, it's the most recent of these test standards. Published first in 2022, it's undergone a couple of revisions since then. It has a ballistic component. It's designed to use an AR-15 style weapon, ballistic, to weaken the elements of the system, including the hardware and the glazing, before a prescribed forced entry attack is commenced. It's a pretty rigorous test with 8 different levels of potential protection based on the energy that's put into that sample. And then finally, ASTM F1233, published first in 1989. This is a very complex ballistic test with forced entry protocols. So it's ballistic and forced entry. It has 12 primary ballistic classes, various results, including fair and unfair shots, penetration or no penetration of the ballistic material through the test subject, and then SPAL or no SPAL are all noted. Forced entry is then commenced with a sequence of 41 different test elements, including a flame test, broken down into 5 major classes and subclasses. The test standard provides some guidance to potential buyers for how you might classify the risk and the threat for both forced entry and the ballistic piece, broken down into 4 major categories: residential, commercial, industrial, and kind of high-risk assets. Notice that there's nothing mentioned about schools in that particular standard. And when we think about schools, we think about places where enhanced security requirements overlap building code requirements. And as Irma touched on before, glazing is often asked to do a lot of things in a building. And for us, our primary concern here at TGP is about fire. There's 3,200 plus fires annually in buildings, educational buildings specifically, and that ties into the second most frequent target site in active shooter incidents. So there's this real intersection of potentially having a threat, whether it's fire or an attack, that could join up in a single system, and you have to provide protection for that. So depending on the assembly, its context, stipulations in the building code, it may be required to meet any or all of a number of fire-rated standards first, including UL 9, UL 10B or C, UL 263, UL 1784, and NFPA fire codes, NFPA 80, 252, 257 as an example, or even ASTM E119. It's important to note that all the components, the hardware, the glass, and the frame, must meet the required minimums for specification here. Enhanced security components, like forced entry and BR, must not interfere with the accessibility and egress requirements of that fire-rated system. So if you think about barricade devices, these may not allow free egress or meet standards outlined in the Americans with Disabilities Act. So there are some challenges in creating what we consider a multifunctional fire-rated material is our core here. A system really is only as good as its weakest link. So when fire and life safety requirements intersect with enhanced security goals, it's important that one form of protection not compromise the other. So there are some challenges here. In most product testing, components are rated to a single standard type. For example, fire resistive elements are only tested to fire standards, and security elements, they're only tested to security standards. So this leaves a gap in how components perform during threats outside their intended scope. Simply adding components together into one system may inhibit the overall performance of the system as a whole. While each of these components must pass test standards on their own, using incompatible components could result in unintended risks to occupant safety. For example, many security-rated components are plastic-based, and they can burn quickly and at great intensity, potentially inhibiting the ability of a fire-rated component to protect occupants. The temperature rise requirements can be exceeded, and maximum temperature parameters of testing standards may not be met, resulting in improper performance of the system. Hardware meant to impede unauthorized ingress must also allow free egress when used as part of a means of egress system. So looking at these multifunctional fire-rated glazing systems, when seeking solutions, a system approach ensures that solutions live up to its intended requirements. Multifunctional fire-rated systems combine compatible security and fire-rated components, which are tested as full systems to multiple standards. With each component within a single system jointly tested to both fire and safety standards, specifiers, buyers, building owners, occupants can all have confidence knowing that the product will operate according to all the required test protocols. Narrow steel frame profiles, for example, provide a close visual match to adjacent non-rated systems. This is important for achieving a cohesive look and for minimizing alarm in both students and faculty. This image and the previous one from the last slide are from two recently completed elementary school renovations. These projects focused on enhancing security from the campus perimeter to the classroom door. The security vestibule, similar to what David was speaking to earlier, was one of the several security measures included in the retrofit scope. The interior doors, side lights, and transparent wall panels allow front desk staff to visually assess visitors and to monitor the parking lot and the main corridor. Helping to meet the voluntary safer school design goals, the security ratings for these glazing assemblies provides a barrier against exterior threats, buying occupants time to alert authorities and to take appropriate action. The interior doors and side lights also need to meet fire-rated code requirements. In addition to achieving forced entry and ballistic resistance standards, the clear wireless fire-resistive glazing assemblies met building code requirements to support free egress during a fire emergency. These systems work with the overall design of the school, the front desk staff facing forward in a centrally located office to provide maximum effectiveness of multiple security measures incorporated into this project. So finally, the Partner Alliance for Safer Schools, or PASS, recently posted a white paper discussing how fire doors for compartmentalization can be used to support enhanced security. These doors can be used as a barrier between violent threats and occupants if designed to allow free egress when necessary and controlled ingress during a lockdown scenario. Classroom doors and openings can also support both security goals and fire and life safety code requirements when these openings incorporate multifunctional fire-rated glazing systems. Fire plus security glazing can allow for visual assessment outside of classrooms, keeping students safe and staff safe in the event of a fire or an intruder. And this also holds true for glazing in stairwells and exterior windows. And with that, I'll pass it over to Teresa.
Hi, everyone. My name is Teresa Ham-Modley, and I'm excited to be here today to talk about safety and security in the K-12 school work that we do in and around the DMV. A bit about VMDO. We are a mid-sized firm working in the Mid-Atlantic, focusing on education and community design. And we believe quality and enduring design can transform a place and elevate the human experience. We are a firm of about 80 people across two offices, one in Charlottesville and one in Washington, D.C., and we have about 45 years of practice. In the DMV, so that's DC, Maryland, Virginia region, we have worked on several K-12 schools for DC, Arlington, Fairfax City County, Montgomery County, and we are really proud of our record in high performance design. All of these schools are designed to be net zero energy ready at a minimum. Most of them are net zero energy. Today, I'm going to focus on two different case studies. One for DC Public Schools, the Truesdale Elementary School, which is in an urban setting in the heart of DC. And the other one, George Mason Elementary School for Alexandria City Public Schools, more of a suburban campus. The first school, Truesdale Elementary, is in the Brightwood neighborhood of Washington, D.C. The project included the modernization of a 1930s historic masonry schoolhouse building, the demolition of a 1965 building, and the new construction of an academic and community-focused building to support the growing enrollment and expansion. A primary design goal of the project was to maximize internal connections and preserve open space on campuses for learning and play. The new academic building aligns with the historic building along the front main street, and the new community building is set back to allow for a protected interior courtyard that serves as an outdoor classroom as well as a playground for the youngest learners and the Child Development Center that will lease the basement floor of the building B. These buildings are connected by a bridge that allows for an enhanced visual connectivity in this protected internal courtyard space. This campus also includes a larger play area on the west side, open to the community during the weekends, as well as a soccer field, parking, and a bioretention area that manages all the stormwater for the local DC requirements. So you can see that visual connectivity within secure boundaries is a key design element of this urban school campus. When we plan for happy schools, we're thinking about physical security at the site scale, at the building scale, at the learning wing or neighborhood scale, and at the classroom scale. At the site scale, we are using both passive and active strategies to define boundaries like landscaping, sidewalks, and canopies, increasing visual surveillance through strategic glazing and night lighting for eyes on the street and external learning play areas, and protecting outdoor spaces using the building form, landscaping, and perimeter fences, as we can see happening here for the outdoor classroom and play areas in the center of the campus. We work closely with school districts to understand their pickup drop-off routines and implement secure entries to the site. At Truesdale, the new main entrance has shifted to the connector space in between the academic buildings along the north-south axis of the building, allowing for a more gracious entrance plaza for families to gather in the morning. Along the west side of the property, the west entrance also serves as an arrival entry point, allowing students and families to gather on the playgrounds before the start of school. This area will also be available to the community on weekends, as well as the community garden in the northwest corner, the soccer fields, but access to the rest of the campus is isolated with perimeter fencing, as you can see with the dashed lines. The front entrance has layers of security, which I'll talk about in more detail in a few minutes. And the west entrance also serves as that community entrance I just spoke about. The gym and the dining commons are used in that south building during after hours as well as the playground areas. During these times when the community is using the building during after hours, the rest of the academic buildings are isolated and inaccessible through lockdown, controlled entry at the doors at the bridge. So as you can see, on a given school day, we provide one secure way into the building, but many ways out for safety and egress. Here's the front entrance with that open hardscape plaza for family gathering that I spoke about. At the first level, the storefront glazing has a faded frit pattern up to about 3 feet to provide added security to the conference room and the welcome center there on the other side. And our secure building entrance has multiple layers of protection. The first vestibule in this sequence is a weather vestibule, which is critical for maintaining balanced temperature and humidity inside our high-performing building. The second vestibule is a gracious 2-story tall security vestibule with a sign-in desk that all guests have to check in at with the security officer on site. From the vestibule, all doors to the corridor are locked. Guests must enter the Welcome Center before entering the school. And in the event of an emergency, the doors into the academic wings, the bridge, and the stairwells are all on the lockdown emergency plan, providing an additional layer of protection. In this space, there's a lot of visual connectivity, but physical barriers with the storefront glazing. That is all a laminate interior glazing. At the classroom wing level, we cluster classrooms into communities while sprinkling in administrative rooms on the floors for added staff engagement and visual surveillance. Lockdowns occur at the corridor level with access to stairs controlled by the lockdown hardware as well. At the classroom level, we design classrooms to maximize daylight and visual connection to the outdoors, returning always to our ethos that high-performance buildings should inspire and delight. All classrooms have ample access to daylight and outdoor views, protected by drop-down interior shades. And we are always thinking about the view shelter in each classroom from the corridors. As you can see, it's indicated on these floor plans with a darker blue. Everywhere within the darker blue shaded region are areas that are not visible from the corridor. In between academic corridors, we situate the flexible discovery zones for teachers to use as breakout spaces. These discovery zones fall in the glassy connector with direct connections to the outdoors, but from the upper levels, the second and third levels. So just wanted to share with you some images of our classrooms with the large outdoor or south-facing, in this case, this classroom south-facing windows with exterior shades and interior shades. And this is a typical classroom portal from the corridor into a classroom. In terms of safety glazing, our clients at DCPS require physical attack resistant glass at all ground level and accessible locations. You can see here in their EdSpec requirements, they require protection meeting UL 972 5-AAL ratings for 6-minute resistance to for 6 minutes, equivalent to a School Guard 4 rating, or School Guard glass SG4 was their standard. What we provided them was the laminate Defend Ed glass attack resistant security glazing by McGrory Glass on the 4th surface of our IGU unit, integrated into the IGU unit that is a Solar Band 70 glass on the first surface. Here is just a chart of the different Defend glass types, and we ended up going with the Defend Ed, which was a little bit more robust than the 6 minutes resistance. I think the Defend Ed has a 14-minute resistant rating. I just want to return quickly to the protected outdoor courtyards central to the design and share a few more visuals on how this is working. You can see here in blue, those blue dots kind of indicate all of the glazing that looks out onto these interior courtyard spaces from the different buildings that surround it. And in section, you can see the clear north-south central access from the main entry into the community building across the bridge and into the dining and gym spaces of the south building, the community building. Visually, the experience for the children as they head down to the cafeteria for lunch is very open and connected on this bridge, allowing them direct connection to what's going on in the play areas and the outdoor classroom. These are images of the gym and the dining hall spaces, the 2-story height spaces in that academic or the community bar facing out towards the soccer field. And this just represents those layers of connection within the courtyard that are also well protected from the perimeter of the campus and from the street. And just one final picture of that courtyard. Moving on to Alexandria City Public Schools, we are currently in final design phases for this school, which is also a modernization of an existing campus with a historic renovation component. Through design, we iterated on various campus massing approaches, and with the community's input, we landed on this open heart concept, which has a lot of similarities to the Truesdale Elementary School project. The scheme consists of 2 densely programmed bars flanking a central shared indoor-outdoor space. A few key features is that, maybe moving along here. A few key features of this space is that we really wanted to connect that internal loop with the external loop of circulation and its solar orientation, maximizing views into classrooms. This school also has a historic component. We are looking to maintain the historic front entrance of the building and replace all of the glazing of these with new fixed offset windows. And on the first floor, they will have security glazing. This is a view of the aerial view of the open heart concept. And as you can see, we're using similar concepts to the Truesdale School, looking at layers of security from the site to the building, to the academic wing, to the classroom. Circulation through the building was a key component to our design with very clear entry points into the building and into the outdoor courtyard spaces. Another key design element is extending the tree canopy from the site, that existing canopy, and mimicking that in and around the building space. Similar to Truesdale, secure entries for arrival and dismissal and for community use are critical to our design and layout of the building. And separating the community spaces from the academic spaces so that they can be used during off hours and isolated from the academic bars. In this project, the owner required a school guard glass on all exterior, I think it's first and second level glazing, and we have specified the child guard glass with forced entry resistance. In addition to that, we are looking into using Bird Smart Glass for a lot of the glassy connectors in the corridor or in the interior courtyard to protect the glass. It's also becoming a new code requirement in our area. And finally, that interior views out are very important, and we are protecting our glazy connectors with an integrated solar screen that is meant to mimic the dappled light of sun entering through trees. This is just a final visual of the interior courtyards. And of the building from the play areas. Thank you very much.
Thanks, Teresa, for that. With the National Gas Association, we have quite a few different papers and resources, webinars, magazine articles at our disposal, and these are all links that you can click on there. Also on our website, we have quite a few bit of information on anything school security or glazing or protective glazing in the industry. Dean, I'm going to put it back to you now.
Have come up. We've got time for a few. Everybody who's listening in, we also have a survey at the end that we'd like you to fill out. It really helps us continuously improve these webinars. But Teresa, you and David, there's a question I had about that came in about when you're working with multiple different glazing types, say on the first floor, I think you said in Truesdale, and then on the first and second floors at the one in George Mason, that are impact. I couldn't get the level exactly of how forced entry resistant they are, but maybe not necessarily ballistic resistant, but forced entry. Is that correct on the George Mason School?
Yeah, that's correct. In most of the school districts that we're working with, we have not come across ballistic requirements yet. Most of them are just forced entry level. Mm-hmm.
Right. Unfortunately, the trending is not good on that. But that said, you're working on those different levels. Say on the first level in Truesdale, then on the second level, it's a different level of entry resistance. Same glazing manufacturer, and then maybe at the vestibule you have an even more secure. How does the architect work with the glazing manufacturer? I'm assuming it's just one manufacturer. How do you work with them to coordinate the different levels of resistance that the glazing has and maintain the design impact and intent that you have? And the same, I was going to go back to you, David, on this, because you're reworking that vestibule entry right now. We're reworking the framing. And maybe go to you right after Teresa. So do you spec different types of glazing, and how does that work, and how do you work with the manufacturer?
I mean, typically we're speccing 3 or 4 different glazing types throughout the project or IGU units. So we're working usually with one manufacturer, and in terms of the safety glazing layers, it's often a third party that they're bringing in into the spec or into the requirements. So we're trying to work, often we're working with Vitro, as you saw on my slides, to specify our glass for our projects. And they'll bring in another third-party supplier for the glazing. But we're doing multiple types and trying to, in terms of the forced entry, trying to also manage and balance the performance of this IGU glass and maintaining our low E coatings on that second surface of glass, so that usually the laminates are going on the third or fourth surface, I believe.
Gotcha. Okay. And then, yeah, I mean, I was going to ask again about the sustainability side of all of this and how it impacts your daylighting. And it sounds like you're working with them on those types of things like the low E glazing, et cetera. David, you said that you're now in redesign of that vestibule window. Is that correct? You
Yes.
didn't like the look of it? Okay.
Yes.
So who are you working with to have that meet a more design aesthetic that the client seems to want and still maintain that very high level of security in that vestibule area?
Actually, we're reaching out to quite a few of the reps to see what they can provide, and that's kind of what we like to do. Is we kind of look around and see what everybody has and find our basis design, and then present that to the client to get their input. Try to give them the best solution that meets the requirements they're looking for.
And that framing system that you have in there, is that your design or their design on the framing side of the vestibule window?
That was their design.
Gotcha.
Well,
okay.
I'm sorry. It was one we brought to the table. We presented it. We went through the budgeting, and we ended up with a product that is going to work. That's a rendering right there, so it's not truly reflective of the mullion size because, again, those systems are a little bit thicker.
Okay. All right, and then something that came up, I think, in Ron, in your presentation, but that also seems to be a potential challenge going forward for everyone who's listening in, is this idea of a multifunction security and the increasing levels that we may start needing, at least on the ground level. So you want to prevent entry, but apparently that doesn't necessarily always work if you're shooting from the outside on levels that we would have never even conceived of as necessary before. But in terms of the multifunction, if you have a storm-resistant, in Florida, let's say, glazing system, to what extent is it also ballistically resistant? Does it provide any kind of slowdown? Or do you really need to rethink a complete new idea of a multifunction glazing system that could satisfy many different criteria at the same time?
Yeah, that's a good question, and a really good question. And I think it comes down to, well, it depends on the specific product and products that are used in combination. So a lot of times a particular product that might, say, be fire resistive, some of these products can be inherently ballistic resistant to certain levels, either with no transformation or with minimal transformation. They can meet certain levels, 1, 2, or 3, et cetera, of, say, UL 752. The same is true with these windstorm-rated products. There are multiple outcomes that can happen from a single product or a combination of products. And just because it's been tested for one particular scenario or one particular standard doesn't mean it will or will not have some efficacy to another standard. And it's important to know that you have to test those systems as complete systems to really know that. So because of the number of permutations and combinations that exist, that's a daunting, it's a daunting task for anybody. It's really understanding.
Unfortunately, we're basically out of time, but do you know, in the glazing world, or maybe Irmela, you can talk about this, are there skunkworks kind of research going on to get these combo products out to the market that can solve many problems at the same time?
Yeah, that's what I have on the screen right now, is that the glass is being asked to do so much. And so it just depends on the mock-up. And so you can have a high performance system that has multiple layers of laminated, which offers your, impact protection as well as force entry and security and safety, and then all the way up to ballistics on there as well. But it's still bringing in the daylighting and the views and the acoustics and the fire and everything else. So they do have systems out there. I think it's make sure you talk with your glazing contractor, talk to the glass manufacturers, the fabricators. Many of them, there's many products on the marketplace that are capable of doing so much.
Terrific. Okay, thanks, Irmela. I'm afraid that's all we've got time for. Great presentations, everybody. Unfortunately, we have to think about these things now. We all wish we didn't. But everybody, please join me in thanking Irmela Sowell, Jamie Gascon, David Dumas, Teresa Modley, and Ron Madeley for their presentations, as well as our sponsor, the Glass Association. If you have any questions in the audience or comments, please don't hesitate to click the email us button on the webinar console. And please visit architecturerecord.com/webinars for the archive of this presentation, as well as information about our upcoming events. We appreciate your time and hope you found the webinar to be a valuable experience. Thank you for attending.